That's the easiest way to turn $50 into $5,000. So take advantage of that. All right, yesterday in class, if you, they didn't get a video, so I'm acting like I'm correcting the video, but I didn't get the video yesterday. Okay, yesterday, don't know how it happened, and I'm terribly sorry that it did happen, but I'm going to make sure it's really clear. If we want current, you take voltage divided by resistance.
Yes.
Easy. Okay, if you want voltage, you take what? Whoa, just, what am I doing? I'm all over the place. If you want resistance, R.
Voltage over.
You take your voltage and you divide it by the current. Okay. Oh my goodness. I lied. I want you guys to come check and make him stop, because now somebody's getting a call or something and it's just going bonkers. Whoever this is, you're buzzing.
Oh, that's my mom.
Sunny.
Uh-oh.
That's my mom.
Answer it.
She doesn't speak any
I'm
English, so I
in
don't know.
class is the translated version that I would like.
You want me to call her, or can I
I
call
won't
her?
answer it until I'm in class. Call me back.
Can I go outside?
Sure. Okay.
Sunny yelling at the
So, looking at it, here it is. Now, this leads to a much easier, the triangle that we had yesterday, you couldn't make it work because one of those equations didn't work nicely. The nice shortcut that we should all have, it should work no matter how we do it now. As long as we recognize what's being divided, we're going to be okay. What is in a numerator in every single one of these?
A one.
So,
Oh, I mean.
so it feels weird, but is this a fraction?
No.
Isn't it?
Oh, it is. Yeah. Visible one.
Right? It's there. That's a fraction as well, and this is a fraction, and this is a fraction. What is the only thing that's in every single numerator? Like, no matter, like, on the left or right, something is never in the denominator.
Invisible one. Wait, what?
Okay.
What's the question?
There's never a v in the denominator.
Oh.
Nowhere in here, right? Which makes this so much easier. That means, guaranteed when we make our triangle, to generalize this, if v were either of these, it would wind up in a denominator. It's not. V. Voltage has to be on top of your triangle. It doesn't matter for the bottom two, but 100% it does matter that the v is up here.
Well, I did put that then. We did that yesterday.
So, but it didn't work because remember I covered one up and said, oh, but this doesn't work. How do we rearrange it? Because I was at a loss for why it wasn't working, just as I was at the end of class. It didn't work because I had this wrong.
Okay.
It might have been right on your page, but it doesn't really truly line up with what we had written down. Klein.
So the bottom doesn't matter how it's arranged?
Nope, I times R is the same thing as R times I.
Oh.
But what does matter about the order is where you're sitting in class during the lecture. Sneak it right in, right? I don't know if he caught it.
I don't
Remember
think he did.
Did you bring your glove?
My glove?
Did you catch it?
Yeah.
Yeah.
I was just waiting
To
for it
catch
do-
something,
just
right?
doing
Like,
this whole update.
no, you're good. I'm just kind of messing with you as we're going. Okay, so we got that sorted out. Seems like a pretty natural spot to do some problems. So if you have your computer, which you guys do have them out, set them aside somewhere because we need to work a couple problems. Okay, we're gonna do at least one together. Don't turn them off. Don't turn off the computer, but just set it off to the side because we gotta do a couple problems. Now, looking at this stuff, this equation and our use of this triangle, my hope is it will make things so much easier. What's the value in this triangle and how do we use it?
What?
Like,
Oh.
why do I draw this triangle for you guys?
So it's easier.
Why is it easier? How does it work?
Because like, if you're trying to solve for V, you can just cover up V.
If you, good. If you cover up V, what's happening with I and R?
Multiplication.
They're multiplying, which is what it says to do here. If I want to solve for the current I, what happens between V and R? They divide, and I can see that these things work out. Okay, if you like the triangle, keep using it. If you hate it, don't use it. Your call. Okay, so we have a super short lecture or discussion, I don't know, whichever one you want to call it. But we're going to do at least one together. If we need to do more, we will. Do you guys want to see really briefly the stuff that we're looking at on computers, just so you get a feel for it? Okay, so it's kind of split. Doesn't, like you're going to see it eventually anyway. I don't have it up yet. But when we get to it in physical science, you go down, here's today, here's a link. Good thing you have a spare. Okay. Now, we're going to call a lab. I can hook it with paper or above Vincent there by the pencil sharpener there is. Now, for this, you guys will play around with this without any guidance today. We'll do like a whole thing to work through it tomorrow. But real quickly, I'm just going to make a circuit. Now, we will go into like detailed circuit stuff, and it'll kind of mix in. But if I connect this right now, do you notice that the electricity is not flowing?
Yes.
Why isn't the electricity flowing?
Because there's no circuit. It's not open.
Okay, because there's nothing to go from negative to positive, right? Now, the second I put this here, what are we going to see happen, you think?
We're gonna see positive.
Okay, so apparently I have too much energy. Everything lit on fire. I'm going to turn this down, and we'll see if it'll work here. My guess is it still probably won't. So I'm going to add a light bulb in here, and it's been a while since I played with this. We're going to cut that. We're just going to add a light bulb. Cool. All right, now we're talking. Okay, it's moving slowly. First and foremost, does electricity really move that slow? No, it just doesn't really happen. Okay, now a couple things that I was talking about, and we will define all these, but it's just nice to show you. To get this stuff, I just drag it out here, and then I can adjust it. You guys will play around to like get used to this. Other things, the other day I made a weird comment about like, oh, this is positive and this is negative, and it probably didn't really click. This tool that I have up there highlighted is called a voltmeter. It measures the voltage, the difference in energy between 2 points. If I look here, and I connect the second piece on the wire, is there any difference between if I measure here and here? So what would you expect the difference or the voltage to be? Give me a better answer. That's not a terrible answer. Zero? Zero is nothing, right?
I don't know how many volts are in there. Oh.
It's a 9-volt battery, but my voltage is 0 because there's nothing to measure the difference between. If I were to move this to the other side of the battery, though, there's one on the positive side and one on the negative side, right? Two very different aspects. Now it measures. It measures -6, which is wonky. If I switch these around, now it's +6, because the order that you subtract matters, right? 0 minus 6 is -6. 6 minus 0 is +6. That's all we're seeing, that difference or subtraction. Okay, this is what you guys are going to be playing around with. I'll tell you, it is super helpful when we're doing problems. If you want to check stuff, you can set this up to help you with the problems if need be. Okay, this is where we're going to end up today. But for now, we're going to look at a problem. We're going to be told that the voltage difference, and we're just going to work with a small handheld device. So example, and let's just go ahead and say Ohm's law, which is that voltage is current times resistance. That's what Ohm's law is. Okay, so we're going to do at least one together, and then I want you guys to try a couple, and once I'm confident and you guys are comfortable with it, we'll move on to playing around and messing around with the computer. Cool. So right off the bat, we're told that on a calculator like your TI-84s, a calculator, and you can write a shorter word as long as it's a small electronic device, a calculator has 6 volts, or has a 6-volt battery. I'm just going to say supply because I don't care if it's a battery or whatever. Could be a battery or wall outlet, but 6 volts there would be crazy. So we have a calculator that's powered by 6 volts. Okay, we're told the resistance within the calculator, the wires, the resistance is, let's go crazy here, 1.2 kilo, I'm trying to think of how you would do this. I'm just going to write this. Kiloohms. Cool. All I want to know is what current flows through. What current flows through? Okay. That's it. Now, for these problems, somebody out there, and I'll wait until you guys are done writing because I'm really guilty of doing this. I'll give it a second. Everything okay, Sonny, by the way? With your
Oh, yeah.
Okay.
Oh, yeah. Yeah.
Oh, you were at the other phone. Who's number 2? I need to reprint your list. I don't remember. I don't know. We're missing a bunch. But they might be the people who are missing because I lost my list like 3 months ago. All right. How do we start a problem here? Every time.
Oh, a given.
We start with the given or the known information. Okay. So here we go. Given. I need to be able to write this stuff down. And one of these feels odd to do because there's not very many times in this class where the label and the unit that we use are the same. Very rare. This is one of them. What's one thing I know, Gian?
The voltage.
Okay, so the voltage V is equal to what?
6.
And this is where it feels weird. 6 what?
V.
That feels like cheating. It's not. The way that people get around this, and we can do this if you'd like to, you could write potential difference. I'd rather just write voltage. Or delta V if you'd rather would also work. I'm just going to write voltage capital V. Okay, the voltage is 6 volts. I know some more stuff though. Relly, hook it up. What else do I know?
You know that the resistance
Okay, and what label should I use for resistance?
R.
Good. Here's the most challenging part of this. What is the resistance right now? Like, and that's an everybody question. I write it down. I said, hey, the resistance is this, but I just don't know how to pronounce K horseshoes. That's 1.2 what?
Omega.
Kiloohms, right? Okay, now before we commit to writing that down, when you see K as a prefix, a letter in front, killi means what? Or kilo rather. Okay, it's 1,000. How many ohms of resistance if there's 1.2 kilo ohms?
112.
A little too much.
1200.
1,200 ohms of resistance. Okay. Normally it's given to you in ohms. I just want to hit that so it's a nice little review. Okay, that's all we're given information. What are we trying to find?
Current.
And how do I represent that?
I.
I. Now, as soon as we identify this, there's nothing else that we need to do other than be able to find and use Ohm's law. We are solving for I. Using your triangle that hopefully you put on the previous page, when you cover the I, what is left behind? V over R. I really, really would prefer, and it's in your best interest and mine because it's easier to grade, if you go through the process of writing this without numbers first. It will allow us to fix and find mistakes so much better. Like, there's value in this. Do we know these numbers? Okay, so check it out. What's the voltage? 6 divided by 1,200. We're going to use the ohms, the true ohms. Okay, with your calculators, we get a little tiny number. 6 out of 12 is 0.5, right? But now there's 2 extra zeros. Verify on your calculator.
0.005.
Yep, I just add the 2 zeros at the front. I'm almost good with this answer. Real close to it. If I said how much current, you said 0.005 dollars, that's a weird thing to talk like.
Is it amps?
It's amps. What's the letter that we use for this? Capital A for amps. Now, this is common. This is really, really common. However, 0.005 is ugly, right? This is 5 thousandths. Do you guys agree with that? If I wanted to move this 3 to the right, could I? And that's like multiplying it by 1,000. If you want to make this last step, I think it's natural. 5, and then what's our prefix that we're going to be able to use? 5 thousandths. What's a thousandth? A tenth is a centi, or a milli. Centi. Killiamps is too big. That 5 killiamps would be 5,000 amps. That's like more than every electric chair ever has used to kill people, just so you know.
Do they still use those?
I think some states still use the electric chair. I don't know. I don't put a whole lot of thought into it. Gosh. Well, what's smaller than a meter?
Centimeter.
Foot?
Before you get, so centimeters are small, right? What's smaller than a centimeter? Milli.
Millimeter.
Check it out. We're 5 thousandths. That's the same as 5 milliamps. Now, this is not just me doing this because I like conversions and stuff. Check any charger. Like those of you that have computer chargers, if you look at them, guarantee you're going to see MA written on here, just like that for milliamps. Okay, what did we actually just answer?
The current.
So the current through what?
That flows through.
Flows through what?
Like a supply. 6
The calculator
Oh, really? It was a calculator?
has 5 milliamps of what? current. Boom. Done. Easy, breezy. Beautiful cover girl. Those commercials aren't alive anymore, are they?
Cover girls, like,
That's still, I don't know how to have TV.
I don't watch TV.
Okay, cool. Doable? Everybody feel okay with this?
Yes.
If you don't feel okay with it, be comfortable asking me. I want you guys to try a few on your own rather than just making you say, look, you can write this down and do it. Okay, so on a separate sheet of paper from your notes, because this is your homework, just so you know. I'm gonna give you the entire assignment. I'm most concerned with the first few, but super duper short lecture today because we're gonna start prepping. Homework 6.2 is what we're at, I believe. Right, 6.2? Okay, for this, I know that I really need to do this, but it spans 2 pages, so I'm going to write them both. It's pages 152 and 153. 152 and 153. And I'll even put the problems up on the board for you guys here in a second, but I want you to have them all. 152 through 153. Okay, you get the privilege of working problems 7 through 15.
All, right?
All.
Okay.
Now, that sounds like a lot, except for the fact that we have like 30 minutes of class left, so that should seem like less. Here's my deal. 20 minutes, you should be able to come close to finishing, if not completely finishing. Which means the last 10 minutes of class, I want you to open Google Classroom on your computers, start playing around with that stuff, figuring out how it works. Cool. I'm obviously not just leaving or anything like that. This will be due tomorrow, and I will throw the first few questions up on the board. Sabrina. I will give you mine. Cool. Let me take a picture of this real quick. Okay, or actually, I don't know if you'll need it yet. If you struggle to see this, just let me know. But I'll just put this up here for now. Okay, if you don't want to have to grab your book, I'm fine with that. Here are the first 3 problems that I want you to do. Page 152 and 153, 7 through 15. There are the first 3 problems. Okay, number 9, don't believe that. It says it's a challenge. I don't think I would call it a challenge. Don't let them psych you out. I'm gonna pause the video in case I wind up resuming it, but for now, I'll get some chill tunes going. I want you all to start working on this. Cool. We're paused, I think. I don't know how to tell. Am I paused? I'll throw it back up.